Okay, so welcome to the 8th lecture of software maintenance. Today we are talking about one topic of mine which is really interesting, test automation and how to run or manage test automation systems. I also want to point out that I did grade your previous weekly exercises on the holiday week last week, so go to Moodle to check out if your submission has been approved. Most of them were okay, because I also like to, if you had tried realistically enough, I didn't want to skim out on points because you missed a technicality or on the reverse engineering got one detail wrong but still got the general idea down. So go to Moodle and check out that you have the points that you expect to have. And of course, for those who don't have submissions, please remember that there's a number of them which need to be submitted for grade, but that's really not a problem for most of the students who are actively participating on this course. I think most of you already have 4 submissions in. Anyway, software maintenance. This second part of the course, which starts on this week, is a bit different from the first part. On the first period, the first part, we had more or less lectures, some project assignments, weekly assignments, and so on. On the second part, we only have like 3 lectures left on theory. Then we will have a visiting lecturer at some point during the spring. I have already been in talks with him, and I will be putting more info on it available to the course web pages. We have Moodle announcement, and also talking about it next week before the lecture. Also, the project deadlines are coming, so please ensure that you have submitted everything for the project 1 and for the project 2 before the deadline. And if you find from somewhere mention that this course has seminar days, physical seminars somewhere, that's from the last year's information, and please send me an email to point out where it still says so. Because we have so many groups, it's really inconvenient to arrange seminar which has something like 5 hours of presentations. We use this year an online seminar or online presentations which you will peer review based on the order in which the video was uploaded. Of course, this year's course doesn't have that many students, well, not at least as many as last year's, so we might be able to do physical seminars, but because we are online compatible course, I don't expect anyone to travel to Lappeenranta so that they can give a 25-minute presentation, so we use the online approach. So, last time we had a lecture, we were talking about software product lines and software configuration management. Basically, these 2 things, as a reminder, are more or less the cornerstones of actually having a functional pipeline for releasing products within the modern software development or software product or software service development context. Of course, the configuration management is more or less the idea that you should have some tool or working way in maintenance to ensure that if you fix something, it stays fixed. In olden times, the job of regression testing was to ensure that all the things that were fixed, bugs, problems, missing features, so on and so on, stayed fixed or added when we released new major version. Of course, there's tools nowadays and systems, version control ecosystems which allow us to do this more or less fluently, but even if you are running a small commercial operation, it's just feasible or realistic to use some of these approaches. And like mentioned on the last lecture, having a subfolder hell on your shared drive isn't version control management. It's a method of madness. Similarly, if we have a configuration management, we also have the possibility to select which components we want to use in our products. We might have different versions for different types of customers, or different levels of customers, or different customer groups, or when the customer gets the most recent version which was available when they bought it. If they want to have the new features, they have to buy it, or if you have a subscription-based business model, then you of course give it to all customers, but on some areas of industry and areas of business, this is not feasible approach or something that you might want to use. So the software product lines approach actually tries to emphasize this aspect of software development. We have core assets, which are more or less the fundamental building blocks for all our products. And when we do product development, we select the core assets or features or functionalities on top of which we build our new product. The new product may lead to more core assets, or it might be just a tailoring process or customization process from the existing assets to create something new. And the management process, the third wheel on this side, more or less is the preparatory design approach, where we try to find new customers, new market segments, new areas of improvement, new features, perhaps select from our existing or new products the features or parts which will be upgraded or promoted to core library, and perhaps some core library assets which will be left out in a near future. So more or less this line of thinking tries to emulate the manufacturing industry approach in software development. We have the common core on top of which we have different products, and we have a management process which maintains basically the core assets and the separate individual products or services as different things. We want to consider automotive industry. For example, Ford has its own platforms on top of which they have different types of cars, and when they want to upgrade something, they might decide that only this model has that feature, or our future fleet have this feature when they add it to the core library. The idea being that if you build it once and it works, then you might as well make it a universal functionality or something that's offered from this point onwards on each system. But that's not the topic of today. Today's topic is the test automation, and this is actually interesting from my perspective, simply because this is actually a relatively new thing. More or less all the things I've been talking about on this course are things that has been invented or become actually practical things during the 80s, 90s, and so on. So basically something that was actually already known or applied before I actually got into the industry or research. But the test automation is interesting from my point of view because it's actually something that really popped up when the agile approaches became a reality, and when the computer systems or development environments were universal enough so that not all the companies didn't have to build their own tools. Test automation is something that became reality around 2000, and it was adopted into most software industries afterwards. So of course this is also something like 20-year-old idea, but in reality this migration towards automated testing tools is something that's still going on. So this is something that you will definitely be working with when you try to adapt your software or project maintenance into something that's more convenient or easier to keep up. Of course, you probably all know already what that by the way, that isn't meant to blink. It's just that the overhead projector is having problems today. But anyway, of course, test automation can mean anything. As long as we are doing testing work, running test cases, perhaps configuring the test environment, test bed, doing configuration on the emulation, running a system which analyzes the outcomes. Whatever we do, if we do it with automated tools, it's test automation. This is also something we are going to talk about on the latter part of the lecture, because while test automation can do many things, there's a level of maturity in the test automation tools, and it's worthwhile to understand what's the current state of the art in these things. But let's start with an industry survey to give you an idea on what the test automation actually does. So, okay, we had 115 respondents from the industry. These people represented more or less software testing people, software developers from multinational companies, from companies in Europe, Finland, North America, Asia, wherever. It isn't actually limited, well, strictly limited to certain places or certain types of people. So the idea was to understand what are the benefits and limitations of test automation. Of course, there's huge amount of these studies. There's, besides this Rafi, Moses, Petersen, and Mäntylä, there's also, for example, pitfalls of test automation document, which lists something like 40 the most common reasons why test automation or adoption of test automation fails in software industry. And keep in mind that that's top 40, so there's several different ways of completely cooking this up. But anyway, test automation has some obvious advantages on it. On this particular study, for example, I'll read you because you probably can't see it on this microtext. Improved product quality, improved test coverage, reduced testing time, reliability, increasing confidence, reusability of tests, less human effort, reduction in cost, so on and so on. So basically the idea is that we can do more with the set amount of time, or we can do set amount of things more cheaply, or we can expect our product quality to be better. Because if we run all the test cases automatically, we can do it, for example, every night. We get the daily build out. We know that it works. At least the test cases we have automated works. So we have some sort of reliability that we can actually work with it. On the other hand, the description of limitations is actually fairly perceptive on what are the actual problems of the test automation. The automation cannot replace manual testing. Failure to achieve expected goals. Difficulty in maintenance of test automation. Process of test automation needs time to mature. False expectations. Inappropriate test automation strategy or lack of skilled people. So surprisingly, when we are working with something new or we are working with test automation tools, we also need people who actually know how to use them. Or we actually have to maintain our test automation tools. Our software is constantly evolving, which means that our test automation has to constantly evolve. And this is actually, stupidly enough, a hugely common problem. We have the automated testing tools. Why are you complaining that it doesn't work anymore? We just installed it 2 years ago. Because the test automation tools are what you'd expect them to be, tools. You use them to get measurements or outcomes, but you still have to maintain them. And they aren't actually easy to use tools either. There's really specialized knowledge or understanding on what they do, how they run, how you configure them, how you manage them. And for example, some tools like Robot Framework are something that you actually have to actively learn to use before you can say that it's actually functional. And then when you change something on your product, you also most likely need to do some changes to your test automation, at least the cases you run in it, to accommodate these changed features. And of course, this is something that you'd expect everyone with a sense to actually do, because you have to maintain the source code, you have to maintain the software, so you also have to maintain the tools that validate that your software is still functioning. But for some reason, our research, in addition of this one, I actually know that Mika Mäntylä mentioned as an author of this study. Also, our study conducted by Lappeenranta University of Technology a couple of years ago found out that organizations don't seem to understand that if you don't maintain your tools on test automation, you will run into problems and you have invested into something that actually doesn't work. Also, there's another stupid aspect of this work. Even though the idea is that the test automation increases reusability of tests, it allows better repeatability and it gives us savings against, for example, doing everything manually. But these all are sort of relative things. If we don't design our tests or product as something that can be tested, or our test cases are wildly customized, or something that doesn't have clear path of how things happen, then they are not repeatable. And doing maintenance on the test automation tool, trying to fix it to match the current version of the software, instead of just doing the manual testing and seeing that it works, is actually more costly. So we get reusability, we get repeatability, and we'll get more confidence in doing testing work only if we design the tests and the tools, the product or service so that it can be tested. It's fairly straightforward to get the yes/no answer, and we don't try to automate something that isn't stable enough for test automation. Also, of course, if we manage to do this, we get better quality. Overall, we get more confidence that everything works, and we get immediate measurements, and we get measurements or early warning system that this is going to be a bad batch, sometimes even before we launch something, simply because the test automation says that now, for example, the run-through time of these cases drop down horribly. And this is actually something that we are currently doing as a research, or this is a cutting-edge research on test automation, to get the artificial intelligence or some sort of analytical tool to give us early warning lights, saying that based on our existing knowledge of how this should work, this will not work when we put it into production. But this is, of course, something that's only doable if we have large enough test automation and we have something product that can be tested. Of course, there's some ideas here why some organizations still fight against test automation. Even though test automation tools are more or less available in all development environments or ecosystems worth the professional developers' time, some organizations still find them too costly investment. Of course, as we have been talking about on this course, if we are running a software maintenance on some old legacy system which exists only so that it can serve one purpose for a couple of customers, it's not always worthwhile to do test automation. Test automation is best if we just put it on or start, for example, automating unit tests or integration tests or interface tests when we start a new product. If we just want to create a full test automation to something that already exists, it's going to be a fucking nightmare to make it work. For example, on the project one, you probably have noticed that there's an graded area if you make a test automation tool that runs some tests on the existing source code, which is nice, but I award you points for making a couple of functional automated tests. But if you, for example, would be making a full test automation suite for the 0AD, or the entirety of the 0AD, you will probably spend a couple of months making those cases and expecting that nothing changes so that you don't have to start doing the maintenance or fixing cycle immediately after you put the test automation on. Of course, this on other way means that if you want to adopt test automation tools when you have already running project or in production product which doesn't have these tools, it might take several months to actually get everything running. So you either do feature freeze or just use a baseline product which you expect to function correctly and just start doing test automation on the new features which can be tested after certain baseline in a near history. So of course it needs effort to design and maintain, and it's actually more costly. It's higher investment to buy those tools, use those tools, or create those test cases than just run unit tests by hand or making a small XUnit script that runs when you just before you commit your changes, so that you see that at least this part functions. So of course, if we want to consider what are the most common problems, this reflects back to the earlier talk. So if we want to do successful test automation, we need to have people who actually know how to do it. And because this is relatively new area of development. Really, this didn't exist when I graduated as a master in science and software engineering in 2007, because this was too new thing, and the way people were doing software development and the amount of platforms and release systems or development ecosystems was too varied. So if someone had test automation, it was self-built. Of course, it's completely madness to try to teach that sort of things, but of course today things are wildly different. But still, you need people who are skilled in using these automation tools or building things so that they actually can use automated testing. And this is something that not all development groups might possess, because it's relatively new skill. Also, on some areas, the test automation tools might not actually work, because how things are tested, how things are assured, or what sort of information you can get from the system is simply too varied or poor fit in any case. So you need to have actually some product that is designed to be testable. So you need to have a product which produces some sort of activity logs, or you can measure things, or you can observe things, and you have an access to know what is actually going on in the software itself. And the other one, because like most of the things in software engineering, I'd argue, test automation was introduced with the wrong idea to the software engineering industry. Like UML, some crazy bastard in the IBM decided that they want to use a graphical editor or Paint as their programming language. So they designed a UML language which would enable them to do graphical programming instead of using as an architecture tool it became. Similarly, test automation was something that grew out of the interest of actually getting rid of all the pesky testers and quality assurance people who were always saying that this doesn't work, fix it. So test automation had this weird idea that it replaces manual testing. It doesn't. It won't, it can't, it will never do that. Well, not at least, not the lower levels of test automation. When we get the AI to run those tests, then we might have something different. But in general, the test automation isn't the frontline testing tool. It's just something that ensures that this doesn't break down. This doesn't happen, or this defined thing happens exactly like we wanted it to work. If we find something that's surprising to us, or emergent behavior, or something else, we need to fix it or test it manually so that we can understand what's going on, and then fix it, and then make an automated test case to ensure that it doesn't happen again. This is more or less how it happens. But for some reason, some people got the idea that test automation is something that can fully replace manual testing. Of course it doesn't, because computers are stupid. We can teach them to be better at this, but we run into the oracle problem. Because how can we teach the computer to say that this is faulty and this is not faulty, when it does something that's not exactly, literally exactly as we expected it to be. Also, and then we run into the problem that if we use test automation as something that just ensures that things still work like we wanted them to work, then it doesn't result on any new high priority bugs or problems or stuff like that. So people who don't actually get testing work then see that it's not important then. If it cannot find bugs, it's not needed. But this is obviously wrong because the test automation is meant to actually just ensure that our baseline or the things that we have already fixed stay fixed and not break down again, or that if we have a common core objects or libraries in our product, we don't accidentally do something that breaks them down, and we don't spend one additional iteration cycle week trying to find out the problem because it's emerging somewhere where no problems exist. So finally, there's also a couple of other things worthwhile to mention. For example, the test strategy meaning, of course, the document or the general guideline or the general level of recommendation on how we do quality assurance work. Who does when do we start, when do we stop, what tools we use, so on and so on. Of course, the worth of this document varies heavily between the industries, but still, if we try to automate wrong tests, then we don't get the benefits. We also don't get the quality bump, or we don't get the assurance that this actually works. And actually, one of the most problematic things is that if our product wasn't designed for testability, so it doesn't produce the necessary information or the interfaces or the logs or the points where we can measure and observe and see how things happen, then it's complete nightmare to actually fix or recreate so that we can get the measurements we need. Because if we want to do quality assurance work or maintenance work or see that something works, we need to be able to measure and verify that this actually is something that functions. And finally, of course, testware is usually something that's designed by developers for developers. So usually, or at least when this study was made, the testware, software emulation systems, data collection tools, analysis tools, so on and so on, weren't exactly user-friendly. So you needed to have some experience or skills on this work before you could even start. So, like I mentioned earlier, it's actually also something worthwhile to notice that test automation isn't one thing. For example, if we automate tests, it means that we have this. We can execute a set of test cases, and we have a tool which with diff or something more sophisticated just compares the results. This means that we have a unit testing case with something like XUnit or PyUnit, which you already have been using on this course, for one module, and we see that this still works. But if we actually want to run something that fully works as a test automation, we need to have additional things. We need to have a system that sets up the test environment, loads the test data, creates all the necessary things, configures it so that we just put it to run and then go home and go back to see what happened. We also need something that actually is capable of independently running all the test cases for the different files, for the different systems, and no matter what the result is, actually is capable of saving things and creating a log out of what happened. It cannot be something that when it finds the first problem, it just freezes up because it doesn't know what to actually do. And also, if we want to have it repeatable, then it has to be able to clear up the test cases and clear up the test environment after it has run successfully through all automated tests, because it has to be something that we can just reset and run again, because this is something that saves time and money. Because even if we have automated tests for unit level stuff, when we ultimately end up with something that's a full product or full service, something that runs on a mobile phone, or we have a couple of test mobile sets and stuff like that, or we have a set of emulators or simulators or whatever to run these tests, we spend huge amount of time doing the setup of the environment and cleanup of the environment and running and comparing the results and saving all the stuff, doing the manual labor, sort of, so to say, to get these results out. So of course this means that there's different levels of sophistication within the test automation itself. Actually, this was measured. Of course, this is a fairly old book, but still the idea still holds up. If we don't do necessary amount of automated steps, if we just spend time doing all that, setting up the system, I hope now these wirings are correct and so on and so on, let's run the automated script. We actually spend more time doing a piece poor automation than actually doing things manually. But if we run more mature automation tools, then we actually get the benefits of having more time to do actual testing or having more results with the same amount of resources. For example, if you see here, well, this is like I mentioned, this is a bit old diagram, but still based on a bit old reference, but the idea still holds up. If we do bad test automation, we spend huge amount of time doing maintenance, setup, and analysis phases. The execution runs smoothly. That, of course, happens as fast as we can compute. But still, if we don't have automation around the test execution, we just end up wasting everyone's time and money doing bad test automation. And this is other way of showing it. It's actually the test automation is actually more harmful than it's useful for. But if we want to commit to doing automated tests, it needs to be done correctly. It needs to use the automated tools. And if we are running an old legacy project where we are just maintaining things like adding support for one new type of customer or platform, or adding some new feature for a thing that's going out or at the later stages of the software age, then it's probably not worthwhile to do test automation at all. We just add the feature, check that everything works, spend a couple of days testing out everything we can and saying that, okay, now it probably works, so let's move on with that. Test automation, even if it's a nice thing to have from the viewpoint of software maintenance, not all projects are worthwhile to recreate as fully automated test suites. And then when we go with the more sophisticated tools, we also run into the Oracle problem. And this is something that's really annoying, considering that we want to have a good, reliable test automation. The reliable here is the key word. If we don't have something that's automated and reliable, it means that we have to check manually that the robot or the tool actually did what it was expected to do. And it means that we are more or less just using the test automation as an extra step between running the tests and getting the results for us to observe. And if there's something wrong, we still don't know if it's the problem of the test tool, false positive, or actual real problem, which is a real bug or real problem. So this is actually problematic because skilled human, someone who has experience, who more or less understands how it should be, or knows what is irrelevant, or what is caused by the operating system deciding to start a update cycle at the same time when the test automation was running, or something stupid happening, power outage on a data farm or server farm or something like that. They understand what what is important problem and what isn't. But the Oracle problems comes from the fact that you have to explain this to the computer. So humans use heuristics. So we can, without any more or less training, compare against these things. Is it consistent with history? Is it consistent with our image, meaning that is it something that actually works for our organization? Or something that our organization wants to say about itself? Is it consistent with comparable products? So is it good enough, more or less? Is it consistent with what we claim it to do? Is it consistent with users' expectation? Is it consistent with the product, or is it consistent with the purpose? These are more or less the things that we can use to see if something is just a minor problem, or major problem, or critical problem, or showstopper. If it's something that causes huge problems, then it's more or less, well, I'd say it's quite easy to explain it to the computer that, okay, this is a problem. If it gives you faulty answer to a calculation, of course the automation notices that. But for example, if the camera is just checking out how the mobile phone app works when you just simulate taps on the screen, and something happens a bit differently, the test automation might not necessarily understand that the difference is caused by the underlying operating system having a new update. So it has this hued backgrounds, or has sort of different types of windowing or stuff, or different behavior when you open or close something. Meaning that if you are running a stupid AI or bad tool for test automation, every time your platform, like Android or whatever, updates its default screens, you are screwed, because all your test automation is faulty. Because even though you know that it's consistent with history, and it's still consistent with all the user's expectations and purposes and so on, the test automation tool might show that this isn't working at all. Everything is completely horrible. Now it looks completely different. So how do you explain to your system that actually it doesn't matter if the window has rounded corners or sharp corners or whatever? And this is something that, of course, comes with the sophistication level of the test automation tools. So also, of course, for the sophistication, we can measure, or we can compare several different things. Juha Itkonen, who was the co-author of this course, or the course from which this lecture originated from, actually had a thesis work on how to create test automation tools that actually work. So of course, this isn't exactly a rocket science here, but what we can test, if we have a tool that's testable, we can measure several different things. Screens, what it shows, what happens. Files, what's the contents of the files, outputs, stuff like that. Databases, what happens there. Interfaces, API, what happens in the activity log, so on and so on. So it doesn't necessarily have to have strong support for example, telling you all the time what is going on. But if you are running a test automation, creating a test automation, these are the areas or things you more or less should be able to observe, or should be able to see, at least on some level. Because if you can check all these, then you more or less know that it's probably going to work at the end if you manage to configure your system properly. And of course, based on this, there's different types of approaches. And of course, if we want to measure different things, have different levels of sophistication, we have different types of approaches. This is very crude level of divisioning the test automation tools or test automation approaches into 5 different types of test automation. We have the lowest level of recorded scripts, then engineered scripts, data-driven testing, keyword-driven testing, and model-based testing. These are all completely valid ways of doing test automation, by the way. Of course, some of them are more difficult to maintain or more difficult to update, fix if they get broken, but these all are ways of doing test automation which has been successful in one or several major international corporations, so they are not something that should be scoffed at. The capture replay tools or recorded scripts more or less were the first level or first evolution of test automation. It's fairly simple. We have a tool which captures what we want to do in the real software when the simulation is running, and it's capable of starting the software, putting inputs, reading outputs, taking screen captures, comparing results, and stuff like that. Actually, even the current state of the systems is that they even have an AI trying to figure out if this difference is meaningful or not, or if they are running tests on something like web store. They might even try to figure out if the layout is confusing or not. For example, if we are having a dynamic web page, like, well, everyone should probably already have, because if you are doing your website with a static HTML tables, then you need to seek help immediately. But anyway, the AI system can, from the screen recordings and stuff like that, see, for example, if the buttons render on the wrong order or under some other object, making the site misleading or problematic. But still, the problem with these recorded scripts is that they are really fragile. They go broken the first minute, something happens, and the system decides that these buttons are rendered in different order, or the default size of something changes so that the button is no longer available and you actually have to browse down a bit so that you can press the button. In fact, this is something that some more close-minded people say that capture replay is not a test automation tool at all. It's just a stupid monkey tool tapping on your phone or tapping on your interface and trying to write text when it thinks that it has hit something. But this tool isn't very sophisticated, so it doesn't, for example, try to understand or even guess if there's some changes between the hardware or systems. And of course, if you need to test out things for different systems, large screen phone, small screen phone, website on a normal laptop or desktop computer, so on and so on, you have to recreate these recordings for each and every one of them, because the system is only capable of using the default window and trying to work its way through the cases with that tool. Of course, that means that we have to get more sophisticated. This engineered scripts, more or less, is the level of the XUnit framework. So now we no longer rely on a monkey robot trying to guesswork or stumble its way through the system. We actually have a list of things embedded in the source code or in the different separate set of testable test run modules, which in correct order fire up the certain functions and actions and activities. Of course, this is also somewhat unsophisticated approach, because if you read from the code smells part from the course lectures, having source code which only exists so that it can be run when you want to test things is a source of problems. And yes, it is, because still, even if we have engineered scripts, we have something that we run to do a low-level check that everything works out, the interfaces are answering correctly, the calculations are correct, the system perhaps is doing right things. We have a set of limitations, but also we have the problem that this is actually something that the designer or programmer has to do. Because the programmer has to be sophisticated enough to actually understand what happens in the code, so they can write the debug or self-diagnostics mode into the software. And that's, well, that's going to be a problem in the long run. So we go even further away. We start to separate the self-diagnostics mode or self-test mode. We have still those test cases somewhere, but for example, the different data parts, different things that we want to run are already separated into a test data set. So these are the things that you try to put into the data bank, and this is the information you should probably get. This means that you can actually come up with new test cases by adding new inputs or data lines into the file. If we extend this in a way that we actually can tell the system what it tries to do, we are in a keyword-driven testing. So we have the data, the test data available, and we tell the system what it tries to do. So open the browser, input to the field called field 1 and this, field 2 this, click this button. It should then show something, and at this point, if it should show the title page welcome, and we at that point can tear down the system. So not only have we separated the test data from the system, we also have separated the activities. So we have a separate framework, for example, on Python robot framework, which actually understands what these are, what these activities are. If you have a compatible browser, compatible environment, you just tell the robot framework, okay, that the software is in this site, these are the test cases, and this is the test data. Please do the test run, and then it creates you a report. That's more or less it. And if we are at this sophistication level, then we can also do something like acceptance test-driven development, which means that we actually, when we are collecting or doing the requirements or trying to understand the logic how the system should work, we can create the test case immediately, and then we just make the changes or additions so that we get the system to behave like we want the test cases or the automated test case to happen. This of course shortens the time a bit from the design to the deployment, but it's a sort of a level of test-driven. It's a sort of a sideline of the test-driven development where we ensure that everything is tested by unit tests, or most activities are tested with unit tests because we write the unit tests before or at the same time when we add new code to the system. The keyword-driven testing is actually something that's currently one of the trendy things. This is the highest level of sophistication that most companies tend to aim for. Because even if you aren't a strong developer, understand something from the programming world. Like you have taken the introduction to programming and maybe object-oriented programming, you aren't actually capable of doing software development work, but you are still capable of creating these keyword-driven scripts for the robot to run on your system. And you can add more test cases by adding new data points or adding new branches or activity lists as these test cases mentioned here. So basically, you don't have to put your test data to the source code. You don't have to put your test cases or self-diagnostics mode into your source code. You have your source code, which is only the program. Then you have a framework or the test automation tool, and that has all the test cases and the test data it tries to automatically input into your system. This is a fairly high level of separation and actually something that's very well used. And if you Google something like a Python robot framework, then you will observe that it's actually used in several places. It's also, by the way, developed in Finland, so that's why I'm heavily drumming for it. And this is the robot framework. This This is just the main list of test cases, but this is more or less the notation it uses. You can go to the website and learn more. It's mostly open access. But if you want to go even further, or actually are doing something with the embedded systems or stuff like that, you might want to go even to the model-based approach for test automation. This doesn't mean the old approach where we stare at the UML diagrams long enough so that they start to talk to us. This is something that we model the behavior of the user as a list of or model or state diagram of what the user might be doing. For example, if we are testing a mobile phone, the user might just browse mindlessly on the internet or go to social media, switch music, do something like that, answer the phone calls, use WhatsApp or some other instant messaging tool to send messages. So we make a tool, model on that user. We create a model of the user, what they are generally doing. If we are collecting information what the users actually usually do in our websites, we more or less have the basic functionalities of what the models or the artificial users, robots, might be doing on our site. So we make a model out of it. We make 500,000 of these models, AIs running in our server cluster, and set them free on our test environment. We can see how it works. Or even if it's a really simple situation, like we just want them to test out our microwave or something like that, firmware for our microwave, we give the microwave model, or what happens when you press different buttons at different times, or task of doing these things to the test automation tool, and then it starts to use the firmware in the emulated software. So it uses the microwave, and unlike normal users, where we are limited with time and space and so on, we can create new artificial intelligence or these automation tools to run the software in different permutations of different possible activities endlessly. Or well, not endlessly, but still we can create 500,000 simulated users and set them free on our test cluster or something like that, meaning that overnight we might have tens of thousands of simulated usage hours for our software. All the cases where the system went belly up, something stupid happened, it's freeze-framed and sent for further analysis, where the analysis tools, the Oracle tools, then try to see what happened, and if it's a really finicky one, then it's sent for human observation or the human tester to see what happened here, or the system just writes out why this fell down or what happened on this system. It's a high level of simulation, and that's why only some huge companies like IBM and Intel and people like that are using this. There's some successful lower level systems, and there's some tools which are more commonly available for smaller projects, but these are the latest cutting edge technology wise. So we more or less make a model based artificial intelligence and set it loose using our emulated or simulated software and put work hours to see how it works. And of course, when this tries to explain the same thing. So the model uses or runs randomly or semi-randomly or somehow decides what things it wants to test. It happens within the test execution engine, which is the sophisticated simulated environment, that there's an adapter seeing that when something fails, something unexpected happens, it takes it out from the test execution engine into the underlying system, and well, or actually, it runs the system, and if it finds something that's problematic, it sends it as a log, takes screen captures, memory dumps, so on, and tries to understand what happened or asks the software tester in case it needs to work. So basically, all these 5 approaches are more or less usable ways of doing it. The recorded scripts are something that if you just want to check some user interface things or do some low-level stuff, they are really hard to maintain in practice, but it's a simple checkup tool to see that everything works more or less fine. If we are adding engineered scripts into our system, we of course have more maintainability. We have capability of influencing how the system runs, but still it's not very smart. It's prone to errors, and of course it means that we have to create a separate self-diagnostics mode into our software, which actually fairly usually is also the source of security vulnerabilities, because people manage to get into the admin mode or diagnostics mode and so on and so on. Actually, one warning for this might be that because of these engineered scripts, the American long-range nuclear missiles could be launched by anyone who knew that the test code for the launch activation was 8 zeros, so 0, 0, 0, 0, 0. Because there was a memory leak problem with the system, the self-diagnostics or firing test mode leaked into the actual live firing mode. So if you started the system in the testing mode, put in the activation code, and only then switched to the live firing mode, it was already the computer was already activated, so no one bothered to actually try to get the it no longer needed the actual launch code for that. And this only lasted from early 70s to late 80s when it was discovered that the Atlas missile could have flown that way. No, well, anyway, that gives you an idea why this isn't necessarily the very good idea. The data-driven approach, of course, allows you to add more test data or run data separately. And the keyword-driven approach, where you are using a platform or underlying framework, which then uses your software, is the current let's say, de facto approach of doing this. The model-based approach, when we create a artificial intelligence model to use your software in a simulated environment, is a bit more hardcore stuff. And as mentioned, it's actually really difficult to get to work, but if it works, it's a very good tool, especially if you need to ensure that your service or system can run thousands of simultaneous users, or is robust enough to and doesn't have memory leaks or small stupid problems like that. Finally, if you are doing test automation, you can also do something like acceptance test-driven development. This really isn't the point of very large point on this course, because this is more or less a development method. But for example, not the maintenance approach, but still it's an extension of test-driven development. So if we are capable of using something like robot framework to define what the system needs to do, then we can create the new activities at the same time when we try to create the changes or the new features or needs to our service or product. Meaning that at some points our test automation might actually be ahead of our software product, because the test automation can be adjusted to try to do things that don't exist on our system yet, but we are trying to create it so that it actually works as intended at the end. And like in all cases, if we try to write tests early or try to create anything while we are doing development, we need to have communication. Of course, this is about the test-driven, automated test-driven development, but still, considering that if you are put into a position where you need to try to create test automation for an existing product or legacy product, the first thing you probably should actually ask yourself is, do I really need test automation on this tool? Is it necessary? Is it worthwhile? Does it cost too much? And if you decide to do it, it would be, of course, useful to understand that what you want to do, what sort of tools you want to use, how do you want to involve your, for example, for future changes, your customers, or if you want to increase the agility of your product, make your development cycles shorter, then you might want to consider, for example, the ideas of this automated test-driven development, which explains how you can use these tools, which I ran through on this lecture, to actually make it faster for your organization to develop stuff and use your customers or, well, audience as a test group for your development work. So skipping this automated test-driven development, you can read more on this from the background materials on the course and on the links mentioned there. Like I mentioned, it's a software development approach which more or less emphasizes the use of test automation tools. So it's not exactly stuff on this course, but it's still something fairly interesting, especially if you haven't heard about test-driven development or haven't actually learned about it that much on your earlier courses. But finally, considering that what could be actually used as a test automation tools, these few slides on the end of the lecture, I'm not certain at all that all these links still work. They worked last year, but because of internet, you know that this doesn't necessarily mean anything because it's almost 11 months later now, so of course they might not work, but the names are different types of tools which are useful and available for test automation or testing, so go check them out if you want to use them in your future projects or want to understand them so that you can say, for example, on your job interview or just want to brag about understanding how test automation works. So, to summarize a bit, if you want to automate, of course you need to automate things that are run often. If you are trying to automate things, you probably want to also emphasize or focus on things that are expensive to do manually. So things which require multiple users, stress tests, and a high level of traffic or trying to break the system down. It's very expensive. Assessing reliability or reliable amount of simultaneous users in your infrastructure is something that's really difficult to test or expensive to test. So you might want to try to automate that by having several robots roaming at the system at the same time, perhaps. Also, things which are difficult to do manually, timing critical things, complex sets, difficult comparisons, or performance testing. So if you are trying to, for example, get an embedded system go crazy by sending messages at the wrong order or at the wrong time or at the critical point when the embedded processor might be thinking the last signal before actually listening to the input line again. These are something that you probably want to also automate because doing that by hand is next to impossible. And of course, if you need some knowledge or background information or some heuristic information to understand this problem or not, then you do not automate that. Or if you are doing something for the first time. If you are doing the automated test-driven development, you might want to consider to first establish or understand what it should be doing before you try to automate it. And if, of course, like everywhere, if you don't have a value, you don't have a measuring point, you don't have a possibility to do automation. And of course, usability tests, feel, match, look and feel type of stuff isn't really up for isn't up for test automation unless you are some sort of computer whisperer who can actually explain to a computer how the product should feel and look like in general. So, summary. If we use test automation, we get improved repeatability, surprisingly. We get improved quality. We get shorter feedback loop. If we do it correctly, we also get better use of our resources. More stuff done by the same amount of people, or shorter time span to do all the stuff that needs to be done, whichever your organization prioritizes. But still, keep in mind that the test automation actually isn't something that happens overnight and without any oversight. So it's high initial investment. It needs maintenance. It needs someone who actually understands how it should be done. There are some software products or services on which, from the viewpoint of software maintenance, the test automation is not worthwhile to do. So don't try to force it everywhere, because it will not, on these scenarios, it will not fix your problems. It might fix one out of your 100 problem, but it probably will introduce you 100 new problems. So you end up with the 199 problems by successfully using test automation. So consider, is the high initial investment worthwhile? Is there testability aspects, or is your software compatible, or is it created so that you can actually use test automation tools? Because you are going to face the Oracle problem with your test automation when you are trying to do something more sophisticated than just running unit tests to check out that you didn't typo something. And of course, if you are working in a real-life organization, it should be worthwhile for the people who are managing your portfolio or managing your organization to actually understand what they are buying when they get into the test automation game. For everyone here in this room, and probably most of the people who are listening to this recording, this is a self-explanatory thing. But you need to ensure that your organization actually understands that this costs money. This doesn't just magically make manual testing work disappear. It needs to be maintained. It has a costs associated with it, and it actually requires skilled people to use. So, if you want to remember only one or a few things from this lecture, try to get the idea of the different generations of test automation. What were the 5 different levels of sophistication in test automation, how they differ from each other, and what's actually the useful thing to learn from each level of testing, and also why you should need test automation in your software project, and also why you shouldn't use test automation in your software maintenance project. Both are completely valid issues and problems. So that's that. I will be putting more information on the visiting lecturer in hopefully this week, and giving you the topic and time and place. It will be put online, it will be recorded, so that the long distance participants can also take that lecture. And keep in mind that you have only a couple of weeks to complete the number of mandatory weekly assignments if you haven't started already. And I'd say heavily recommend that you start working on your project if you haven't started yet. Okay, that's that. Let's end the recording, and then I'll have a couple of minutes for more questions.